So we had two coordinates defining a vector for A. Okay, defining the vector for A. So it's always x, y. So you're basically looking for the x, which is 0. So x is 0, and y is -3. So it's straight down. This is our vector A, 0 and -3. And then we have 4 and 0. So those vectors A and B, added them together. They took this part graphically and came over here and came up with 4, -3. You just add the x's. X, 0 plus 4 is 4. -3 plus 0 is -3. Okay? Does that make sense? Does everybody understand what was done here? This one, 6 and -2 were on B. X for A is 6. Y is -2. So we went, which one's that? This one, D. Oh, we labeled them something else. This one is 6 and -2. So this is the first one. And then 1 and -4. 1, well, your 1's a little over, but 1 and -4. Wow, it goes down a long way. It looks like it's as long as the 6th one. I'd probably shorten this up a little bit. And then this can move directly over here, and it comes out with the R, add them together. You add the x components, 6 plus 1, and you add the y components, -2 and -4. So we have 7 and -6 is our resultant vector. Did everybody get that? Did somebody have something different? Does it make sense? Same thing here. A is 2, 1, 2, -3, and B is 4, 4. Take this one, move it up here. Comes out to the resultant vector shown right here. And add them algebraically. 2 plus 4 is 6. -3 plus 4 is going to be 1. So graphically, it looks right. Algebraically, we have a good solution there. And then the last one, we're only in quadrant 1, so the K is 3 and 2. This one K, 3 and 2. Yep, 3 and 2. And then L is 5 and 7, this one. So if we take this and just lay it right up here, we're going to come up with our resultant vector. Graphically, algebraically, we add 3 with 5, 8. 3 plus 5 is 8. We add the y components. 2 plus 7 is 9. You can do it algebraically. So does that make sense on adding these phasors in the rectangular form? This is called the rectangular form. Anytime you just define the x, y coordinates. When we look at any of these phasors, we can also look at them and they have a magnitude and a direction, right? If we look at any of these, they have a magnitude and a direction. So let's just look at a couple of them. And we can define them by that. So if we have our xy coordinate system, and I have A equals 4 and -3. Yeah, I'll leave it -3. 4 and -3. We can define this on the x-axis. We go over 4. 1, 2, 3, 4. And on the y-axis, we go -3. 1, 2, 3. And right about there, we just need the 1 point. because we know it's a phasor. So this has a magnitude and a direction. If we measure from the x-axis, it has a magnitude and a direction. Now, if we're to look at this and use our trig functions, we know this right here. I'm going to use a different color. What's the distance here? Right there. What's that distance in blue? How do you know it's 4? Is it negative or is it positive? Why is it positive? Yeah, it's just a magnitude. It's just the length. That's it. That's all it is 4. But we know it's 4 because it's given to us. That's our x value, right? It's how far it goes on the x-axis. We also have, do we know this value right here? Yeah. I'm going to put it over here. No, I'm going to put it over here. What's that value? How do you know? Given to us, right? It's the y value. Y equals -3. The magnitude up, though, is 3, right? It's not negative. You don't have a negative magnitude. You don't go -4 miles. You go 4 miles, right? Magnitudes are always just a length. And it's 3. It happens to be going down in the negative direction, but it's just the magnitude is 3. And if we look at this, I'm going to make this one up here blue. This is x equals 4. Okay, so we have that value. What do we have there when you look at that? Triangle. A right triangle. A right triangle. And we have all this great information about a right triangle. So we can calculate what that theta is, what that angle is. Right? Can we also find our r? Yeah. How would you find the r? How would we find this r? Say it. Say again.
R equals square root of 4 squared times 3 squared.
X squared plus y squared. We just used this right here. That gives us the magnitude of this would be the hypotenuse, right? R equals x squared plus y squared. We can find what that is. What is it? 4 squared plus 3 squared. I believe that equals 5. Okay, so now we have our r. How do we get theta? We know if we're looking for this angle right here, theta is from the positive x-axis to where our vector is. Yeah, we have our adjacent x, right? It's the one that's touching our angle, and it's not the hypotenuse. And we have the opposite. So we have the adjacent, and we have the opposite. So which trig function would you use? Inverse tangent, right here. That's the one we'd use. Tangent inverse opposite over hypotenuse. So our theta equals tangent inverse opposite over adjacent equals tangent inverse, what's opposite?
3.
Y, yep. Y is opposite. X is adjacent. We defined that over here. Put the numbers in here. Y is 3 over 4. Can someone put that in their calculator?
36.8.
Degrees or radians? Degrees. 36.8 degrees. So R is 38.6 degrees. Now we know the angle and the magnitude, and we're going to write it a little different. And this is called polar form, where we have A. In polar form, we're going to write our magnitude, I'm going to just leave it at R, at an angle of theta. This is called polar form. And angle A, we said R is 5, and it's at an angle of negative 36.8 degrees. Why did I say negative? Yeah, you're going down. We always measure from the positive x-axis. If it's a positive angle, it's going to be up here. If it's a negative angle, it's going to be down here. So in our polar form, we defined that phasor as 5 at an angle of negative 36.8. Let's do, I'm going to erase this and do another one here. Over here. Okay. I'm going to draw our XY. Polar can be on the same Cartesian coordinate system, same one. So let's say we have phasor R equals, 3.6 and 4.9. Okay, so I'm going to draw it. 1, 2, 3, 4. It's going to be in there. 1, 2, 3, 4, 5. In rectangular form. What we want to do now is find this in polar form. So we have our angle and our R. Here, we know this value, because it's given to us, 3.6 equals x. We know this value, because it's given to us, it's our y value, y equals 4.9. Let's find it. The magnitude. Remember, we did it over here. R equals the square root of x squared plus y squared. We already found that because it's just a right triangle. So R equals, what is that? 3.6 squared plus 4.9 squared. When you put these in your calculator, make sure and use parentheses. Make sure and use parentheses. Otherwise, you're going to end up getting R equals the square root of 3.6 squared plus 4.9 squared. Somebody put it in your calculator. See what you come up with. How much? 6.08. 6.08. Did anybody get anything else? We need a second on this one. 6.08. It makes sense to me looking at this. Does it meet the rule of thumb? 4.9, 3.6. Yeah, that's probably close. So I feel confident that the number's correct. And then we know this is true for our theta. We already developed that. Theta equals tangent inverse y over x. Theta equals tangent inverse y 4.9 divided by x 3.6. What does theta equal? Did anybody else get the same answer?
Yep.
Degrees. And that makes sense too because I'm past the 45-degree mark, right? Past that. So it kind of makes sense. So now I can write this in rectangular form and I can write it in polar form. R equals my magnitude, 6.08, at an angle of my theta, 53.7 degrees. It's the exact same phasor, just one describes the x and y coordinate system, rectangular form, and one is the magnitude and direction. Exact same phasor.
How do you know which side of the resultant to calculate the angle?
Ask again.
How do you know which side, like the right side or the left side of the resultant to calculate the angle?
This one or this one? You always do it from the positive x-axis. Always. This one right here. You always come up from here. And that's really key because if you're not all talking the same angle, everybody's going to come up with a different answer. So you have to know which angle you're talking about. And we're always talking about the angle from the positive x-axis. Okay? Questions? Do you guys want to give it a go? See if you can do them? I gave you a few here to try.